This is Algebra 2, Lesson 82. I'm on page 340. So this is more on algebra simplifications. I don't even know what I was going to say. Simplifications. We just have more steps. All right, so you may be asking yourself, why are we doing this? And some of you actually believe this is fun, and it is fun to get to the end. These are going to be bigger. You don't think it's fun?
Oh, I do think.
You do think this one's fun. Yes, I think it's great. See, I think it's fun and challenging and following the rules. It really is teaching you the rules of algebra. And next year, I'm going to remind you people. Do you remember when we resolved complex fractions and made it one numerator over one denominator? We're doing the same thing, even though it feels so much harder. Apply the same rules. We just have to go through the process more than once. Notice in example 1, we have a numerator. That numerator looks beautiful. It's just A. The denominator, that first term, 1, beautiful. The second term in the denominator, however, is complex. So we need to simplify that complex fraction first. All right, so it's A over 1 plus A over 1 plus 1 over X. So you begin where the complex fraction is and simplify it. All right, so I'm going to first make a common denominator. This 1 needs an X over an X multiplied, because all I can do is multiply by what's effectively 1. So I end up with A over 1 plus A over, it's X plus 1 in the denominator over X. See how I got that? I just multiplied, this is X over X plus 1 over X. Common denominator, write the numerators over that one common denominator. Now I'm going to simplify this complex fraction by taking the denominator and multiplying by the inverse over itself. So I'm still only dealing with this piece of the fraction. So I'm going to multiply by X over X plus 1 over X plus 1. This denominator eliminates. I multiply A by X. I end up with A over 1 plus, it's AX over X plus 1. Now, we're back to where we were. See, it's just that added step. Back to the old lesson. Now we need a common denominator in the denominator. So we're going to multiply the first term by X plus 1 over X plus 1. And we end up with A over X plus 1. That's that first term. I'm going to write everything over the common denominator. That's the second numerator over the common denominator. See what I did? This is the first numerator, second numerator, because it's all over the one common denominator. Now I'm going to multiply by the reciprocal. And I will have simplified this fraction. X plus 1 over X plus 1 plus AX over X plus 1, X plus 1 plus AX. My denominator eliminates. I'm going to distribute the A to the numerator in that second, what I'm multiplying it by, that second term. So I end up with AX plus A over this denominator. X plus 1 plus AX. Can anything be simplified? Please say no, because all these terms are added. Yes.
Do you have to distribute in the numerator?
You don't have, you could put A times X plus 1. You can. In fact, in pre-calculus, I will tell you in one situation, don't distribute, because you're going to be able to simplify. There's going to be terms that are multiplied. All right, so just one added step, right, from here to here. All right, so let's look at example 2. Example 2, we begin with b over a plus c over x plus 1 over y. What's my first step?
Go to complex
Complex,
and make it so that
common denominator. So I'm going to multiply this first term by y over y. So we have xy in that first numerator and 1 in the second numerator over its common denominator. Make sense? Got it? Got it, Nathaniel? Are you being honest?
I probably got it. Yeah.
Okay. Do you see where we're starting and why? We're starting where there is a complex term. Not what's a complex fraction? Anything that is simply not one set of values over another set of values. When we have a fraction in the numerator or the denominator. So we're always starting there. Wherever that complex is, the numerator is not complex. The denominator is complex. That's where we're starting with the common denominator. Now we're going to take this denominator, multiply by the reciprocal over itself. So y over xy plus 1, y over xy plus 1. That eliminates this denominator and we'll distribute the c to the y. So we end up with cy over xy plus 1. Again, in the denominator, we have a complex term. This makes it complex. So we're going to go to a common denominator by multiplying the a by xy plus 1 over xy plus 1. So we end up with b. I'm going to distribute that a to both of the terms. So my first numerator is a xy plus a. My second numerator is just cy. And I write it over its common denominator. Making sense? Now I take this denominator, multiply it by the reciprocal over itself. So I multiply by xy plus 1 over a xy plus a plus cy over itself. This denominator eliminates because these terms are multiplied and it's the exact same term. I'm going to distribute the b to the xy and the 1. So we end up with bxy plus times 1 b all over axy plus a plus cy.